movie, we will learn how to draw a graph from a data table, draw the best fit line to the graph, and then calculate the slope from the best fit line. Here is our problem. A car travels on a road. Its position x is recorded in meters as a function of time t in seconds. We are asked to plot the data, draw the best fit line to the data, and to calculate the car's speed from the best fit line. Here is the position time data for the car. In order to draw a graph, we first draw the horizontal and vertical axes, and then, as we did previously, we mark the increments on each of the axes and plot the data on a grid. We notice that the data appears to lie on a straight line, even though not all the data points line up exactly. We therefore draw a best fit line to this data. The best fit line is a line through the data points that has about as many points above it as below it. The best fit line may not go through the origin, that is x equals 0, t equals 0. It may not go through all the data points. In fact, if there is a lot of scatter, it may not go through any of the data points. Yet this best fit line is the best description of this data because it averages or smooths all the irregularities that came from the data collection process. The best fit line then is a way to average or smooth the data. Individual data points have errors due to the limited accuracy of the tools that are used to make the measurement. Drawing a best fit line through the data averages out those errors. We now use this best fit line to calculate the slope. Remember that the slope is given by the rise divided by the run. To calculate the slope, we draw a right-angled triangle using the best fit line as the hypotenuse of the triangle. We make the triangle as large as possible so that it spans a large range of data. The rise now is the vertical height of the triangle. The run is the horizontal length of the triangle. It's convenient to draw the sides of the triangle on a grid line so that we can read off the values of the rise and the run easily. We will need to read the values of the axes to calculate the rise and the run. To calculate the rise, we draw horizontal lines from the edges of the vertical line that we defined for the rise and read off the values x2 and x1. The rise, therefore, is x2 minus x1, which is 23 minus 5 meters or 18 meters. For the run, we read off the values of the left and right edges of the run line. The run, therefore, is t2 minus t1, which is 0.92 minus 0.12 seconds or 0.8 seconds. The slope now is the rise divided by run, which is 18 meters divided by 0.8 seconds, which gives us a slope of 22.5 meters per second. This slope of 22.5 meters per second gives us the velocity of the car. Instead of using the best fit line, what if we used the data points themselves to calculate the slope? Let's try it out. Let's take one pair of data points and use them to calculate the rise over the run, which we shall call slope A. Slope A is rise A divided by run A, which gives us a value of 30 meters per second. For another pair of data points given by the green lines, we get slope B, which is rise B divided by run B, and that gives us a slope of 40 meters per second. Yet another pair of data points given by the dark blue lines gives us slope c, which is rise c divided by run c, a slope of 10 meters per second. So you see, by using different pairs of data points, we got totally different slopes. This is why we do not use individual data points to calculate slopes, but instead we use the best fit line. If you draw a hand-drawn graph, this is what your graph might look like. You would go about calculating the slope in exactly the same way as was shown in the computer-drawn graphs.